AP Calc 1.2, day number 1, representing functions. Our objective today is to use formulas, graphs, tables, and words to define and represent functions. I'm not writing all this out, but we're going to use formulas. We're going to use graphs. We're going to use tables. And we're going to use words. I'm kind of disappointed in myself. I just used a W in purple. I dislike the Vikings with a passion, so that hurt to do that. Using formulas, we're going to review polynomials, rationals, algebraic functions, exponentials, trig, blah, 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 all that good stuff. First thing we're going to talk about is linear functions. So slope-intercept form. Oh my goodness. There you go. The slope of this function would be 3. The y-intercept would be 5. That means I know at least one point that's on that function. It'd be 0, 5. Okay, so slope-intercept form isn't that great because you have to have one special point, that y-intercept. But point-slope form is much better because you can have any point and a slope. And here's the formula. For example, y minus 2 equals negative 2/3 x plus 5. Well, I know the slope of this equation is negative 2/5, and I know one point on that line is going to be negative 5, 2. Okay, this point right here can be any point on the line. It doesn't have to be the y-intercept. Okay, two lines that have parallel slopes. Okay, y equals 7x minus 11, and y equals 7x plus 32. Okay, they have the same slopes, so they're parallel. Perpendicular slopes. Slopes are perpendicular if they're opposite, as in sine, opposite reciprocals. Okay, so here I have y equals 4x minus 11, and over here I have y minus 2 equals negative 1/4 x plus 8. All right, you'll see their slopes are opposite reciprocals, therefore they are perpendicular to each other. All right, so let's find and graph the linear function that passes through those points. Okay, write the equation of this function in point-slope form and then slope-intercept form. All right, so let's sketch it. Write 2 down 3. There's the point 2, negative 3. And then 1, 2, 3, 4, negative 4 up 1. Negative 4, 1. So before I do anything, I probably want to find the slope of that line. So take y minus y divided by x minus x. So I got to go in the same order. So I got to start with negative 4 minus 2. Looks like I get 4 over negative 6, which I would write as negative 2/3. Honestly, I wasn't thinking about that when I made the previous example. It's all good. Okay, so in point slope form, y minus a y value equals the slope, x minus an x value. I've got some choice here. The thing I don't have choice with is the slope. The slope has to be that. But I have choice. I could use either of these 2 points. Right? So I'm going to use, I don't really care. Let's go with negative 4, 1. So the y value is 1, and the x value is negative 4. If you went the other way with it and use the other point, that's fine too. If I want to, so this would be point slope form. That would be good to go right there. Chicken dinner is ready for you. Now, if I wanted to write this in slope-intercept form, I would first distribute the negative 2/3. And what would that be? 8/3. This right here is 3/3. So if I add 3/3 to negative 8/3, I get myself negative 5/3. And that would be the slope-intercept representation of the line going through those 2 points. Okay, let's look at and find a value of k such that 2x, this is a line, 2x plus k times y equals 10 is perpendicular to 5x plus, I think that's, 2y equals 6. So basically, I want to isolate their slopes. Let's do that. Let's isolate them. So this would be k times y equals negative 2x plus 10. So that means y equals negative 2 over kx plus 10 over k. This means nothing to me right now. I don't really care. All I care about is this. Okay, and now I got to work the other side of this. Let's subtract 5x. So I get 2 times y equals negative 5x plus 6. So that means y equals negative 5 halves x plus something I don't care about. So it looks like the slope of this is negative 5 halves. So I want this negative 2 over k to be equal to the reciprocal of that. Okay, so to me, I mean, you can negate these negative signs. It looks like I want k to equal 5. Okay, let's keep going. Piecewise functions. Awesome. These functions have different definitions on different parts of its domain. A function is considered piecewise linear if all pieces of the function are linear. So let's sketch this out. Let's go negative x. All right, so I'm gonna draw this in red real quick. So negative x. There's negative x, right? It's got a slope of negative 1. However, this function is only good if x is less than 0. So I'm going to put an open spot there. So that's what that would look like. I'll erase the rest. Okay. X squared if x is between 0 and 1. Okay, so let me go out here to 1. If I plug a 1 in x squared, I'm going to get a 1 out. All right, so if it's between 0 and 1, including both sides, I kind of get something like that. Okay, and then the function equals 1 if x is greater than 1. So greater than 1 is just going to equal 1. Now that is not a linear piecewise function because all portions are not linear because of that quadratic in the inside interval. Okay, but that would be the way to graph that piecewise function. Let's write an equation for this function. Okay, so it comes in 3 stems. That was brutal. Let me try that again. That was a little bit better, but not great. Okay, so if x is between, I'm going to have issues with that notation. If x is less than or equal to, or greater than or equal to 0, right? I see a closed circle at 0, or less than 1, the function would take on that value. So that's just the line y equals x. Okay, the second piece, if it looks like x is between, inclusive on both ends, between 1 and 3. Okay, this is a little bit funky, but I know a point. To write an equation of this line, all I need is a point and a slope. Okay, I could find the slope relatively easily. Y minus y over x minus x. And 0.5 over negative 2 is the same, fractional experts, as negative 1/4. So that's the slope of the line. And it looks like, yep, x minus 3 would work, right? So if I had written out in point slope form, I think we can agree that I could write it out like this. And since I have y minus 0 over here, technically it'd just be y equals that. And that's exactly what we're looking for here. This is f of x, which is y equals, right? And there's the equation of that line. Okay, and then the last piece is relatively easy, right? If x is greater than 3, what is it? Well, I'm sorry. Yeah, if x is greater than 3, what is the y value? The y value is always 2. So that'd be a piecewise representation of that function. Okay, here we are. Now we're on to tables. So we've looked at graphs, we've looked at formulas. Let's move on to tables. Yeah, so there's a lot of work to be done here. What this question is asking is if the functions f and g have values shown in the table, for which values of x would f of g of x be equal to g of f of x? So let's test it for 1. F of g of 1, would that be equal to g of f of 1? So we got some work to do. we're going to do the same thing, although we can use the fact that this is multiple choice to our advantage. Okay, so f of g of 1. Well, what's g of 1? G of 1 is 2, so this is f of 2. What's f of 1? F of 1 is 3. What's f of 2 now? Well, f of 2 is 4. And g of 3 is also 4, so it checks. So for x equal to 1, check. Okay, so let's knock something off here. Looks like we can knock part E off. Doesn't have 1 as an option. Okay, let's do the same thing for f of 2. I'm going to pause the video and we'll check for f of 2. Okay, so I did x equals 2. X equals 2 does not check. Okay, it doesn't work because those two don't come out to be the same, so we can knock off, looks like we can knock off A. All right, try the same thing at home for x equals 3. So for me, x equals 3 did not work either. So x equals 3 doesn't work. I can eliminate that out of my possible options. Looks like that. And if I were smart, I'd skip x equals 4 because it looks like it's going to work. I'm going to just check x equals 5. So I'll do that one online here. F of g of 5 is equal to g of f of 5. Well, is it? Let's see. G of 5 is 3. F of 5 is 2. It looks like f of 3 is 5 and g of 2 is 1. That's not true. So x equals 5 doesn't work. So that means I can eliminate this option. Looks like D is our answer. Only works for 1 and 4. All right, so we're going to move from tables to words. Classic type question, checking your understanding, right? So where does the curve y equals e to the negative x minus 2 intersect the x-axis and the y-axis? Well, let's think about that for a minute. If it intersects the x-axis, that means for sure y has to equal 0. So if y has to equal 0, then I can plug a 0 in here and solve. So 0 equals e to the negative x minus 2. Now I solve. That would mean 2 equals e to the negative x. And if you're not familiar with the natural log, you're going to be by the end of this course. Okay. Property of logarithms allows me to bring this negative x down in front. And our friend natural log of e is 1. So negative x equals natural log of 2. Okay, the natural log of e equals 1. This equals 1. Okay, that's why I get that. Now let's work through the rest of this. That looks like negative natural log of 2 equals x. Well, I don't see a negative natural log of 2 anywhere. I see a natural log of 2 and a natural log of 1/2. Another property of logs. This negative symbol is like a negative 1 out in front. I can do the reverse of what I just did with the natural log up here. Right, I pulled that negative x out in front. Now I can put that negative 1 up as the exponent. Well, I still don't see that as an answer. Well, what's 2 to the negative first? It's 1/2. Okay, so at x equals 1, natural log of 1/2, looks like I can eliminate this. I can eliminate this. I can eliminate this. I'm just checking to see if y would equal negative 2 or negative 1. Okay, so where does it cross the y-axis? Well, it'll cross the y-axis when x equals 0. So I'd have y equals e to the 0 minus 2. Ooh, someone's going to fall for this. Someone will fall for this because they'll think e to the 0 is 0. It's not. It's 1. So y equals negative 1. And there's our answer. This is out. Our answer would be C. That is 1.2, day number 1. Have a great day.